Humanity's gaze has always been fixed on the moon, a silent, stark witness to our existence. But what if that barren rock transformed, blooming with life, breathable air, and thriving cities? What if the cold, gray orb at our night sky became a vibrant, living world, a second home for Earthlings? This isn't just a fantasy, it's a monumental engineering challenge that, if overcome, would fundamentally reshape our understanding of humanity's place in the cosmos. Right now, the moon is a profoundly hostile place. It's an airless void, bathed in unfiltered solar and cosmic radiation with no protective magnetic field. Its surface temperature swings wildly from a scorching 120 degrees Celsius during the lunar day to a frigid minus 170 degrees Celsius at night. Without an atmosphere, there's no pressure to hold liquids, meaning any exposed water would instantly boil away or freeze solid. The gravity is a mere 1/6 of Earth's, not enough to comfortably hold a significant atmosphere over geological timescales, and certainly not strong enough for human bodies to thrive long-term without consequences. Its surface is covered in abrasive, toxic regolith, a fine, powdery dust made sharp by eons of micrometeorite impacts, ready to clog machinery and irritate lungs. And constant micrometeoroid impacts mean that anything built on the surface is always at risk. It's a dead world, beautiful but utterly unforgiving. So, how do we begin to change something so fundamentally desolate? The first, most immediate step would likely be building self-contained, pressurized habitats. Think vast, interconnected domes made of advanced composites or 3D printed lunar regolith, shielded by layers of excavated soil. These would be our initial outposts, miniature Earths under glass, complete with recycled air, artificial lighting, and hydroponic farms. They would be engineering marvels, but still just isolated bubbles in a vacuum. To truly make the moon habitable, we'd need to go far, far bigger. We would need to give it an atmosphere. This is where the scale of the undertaking explodes. Creating a global atmosphere for the moon is not a task for a single generation, but for centuries, perhaps even a millennium. One proposed method involves outgassing volatiles. We know there's water ice at the lunar poles, hidden in permanently shadowed craters. We could melt it, releasing water vapor. But that alone wouldn't be enough. We'd likely need to import vast quantities of frozen gases like ammonia, methane, and carbon dioxide from passing comets and asteroids. Imagine fleets of robotic prospectors capturing these icy bodies from the outer solar system, redirecting them on long, slow journeys to lunar orbit, then deliberately crashing them into the moon's surface to release their precious cargo. This bombardment, carefully controlled to avoid catastrophic impacts, would slowly build up a thin early atmosphere. As these gases accumulated, they would start to trap heat, raising the moon's average temperature. We might even deploy vast orbital mirrors to direct more sunlight onto the lunar surface, accelerating the warming process. This could trigger a runaway greenhouse effect, transforming the moon into a hot, Venus-like world initially. But that extreme heat would be necessary to vaporize even more water and release other trapped gases from the regolith itself. Eventually, we'd aim to stabilize it at Earth-like temperatures. But here's the twist. The moon's weak gravity is a major problem. Without a strong gravitational pull, the solar wind, a constant stream of charged particles from the sun, would relentlessly strip away this newly formed atmosphere, much like it did to Mars billions of years ago. It would be like trying to fill a bucket with a hole in the bottom. To counteract this atmospheric loss, truly heroic engineering would be required. One audacious concept involves building a colossal electromagnetic shield at the moon's L1 Lagrange point, a gravitationally stable spot between the Earth and the moon. This magnetic umbrella would deflect the solar wind, protecting the nascent atmosphere. Think of it as a giant invisible force field miles across, humming with power, costing more than the entire global economy could currently produce in centuries. Even with such a shield, maintaining an Earth-like atmospheric pressure and composition would be an ongoing battle, a continuous process of replenishment and adjustment. Once a stable atmosphere begins to form, even a thin one, we could then start to introduce water. The newly melted polar ice, combined with imported cometary water, could begin to fill the deeper lunar basins, creating vast, shallow seas. The moon, currently a dusty gray, would start to reflect blue light back at Earth, a shimmering azure counterpart in the night sky. The presence of liquid water would be transformative, providing a medium for life and a buffer against temperature extremes. With atmosphere and water, the next step is life itself. We'd start with extremophile microbes, hardy bacteria and archaea capable of colonizing the barren regolith, breaking down minerals, and beginning the process of soil formation. Then would come pioneer plants, genetically engineered to thrive in the low gravity, high radiation, and still developing soil. Lichens, mosses, and hardy grasses would slowly spread, adding oxygen to the atmosphere through photosynthesis. Forests would eventually follow, not the towering giants of Earth, but perhaps shorter, broader, more resilient forms, creating a complex ecosystem. Picture it, vast swaths of green, punctuated by crystal-clear lakes, all under a sky that for the first time in billions of years actually has clouds. But what about the gravity? This is the one factor we simply cannot change. 1/6 g would forever define lunar life. Human bodies would adapt, but not without profound changes. Children born and raised on the moon might develop longer limbs and different bone structures. Their hearts might struggle with the increased demands of Earth's gravity, making a return journey to our home planet a significant physiological challenge. Lunar sports would be entirely different, a graceful, slow-motion ballet. Agriculture might yield taller, spindlier plants, or require entirely new methods to cope with reduced root anchorage. Even the way we move, build, and interact with our environment would be fundamentally shaped by the constant feeling of lightness. Imagine a moon where you could leap over small buildings, where every step is a floating bounce, and heavy machinery becomes manageable with far less effort. The implications for human society would be immense. The moon would become a safety valve for Earth's overpopulation, a vast new frontier for expansion. Lunar cities, initially underground to protect against radiation and micrometeorites, would eventually emerge onto the surface, protected by the new atmosphere. A unique lunar culture would blossom, distinct from Earth's, perhaps emphasizing resilience, innovation, and a deep appreciation for the delicate balance of their artificial world. New industries would emerge: helium-3 mining for fusion power back on Earth, scientific research in the unique low-gravity environment, and a booming space tourism industry unlike anything we can currently imagine. The concept of Earth-Moon system wouldn't just be an astronomical term, it would be a unified civilization, two worlds bound by a common destiny, sharing resources and expertise. Politically, this would be a minefield. Who owns the moon? Would it be a collection of independent lunar nations, or a federation tied to Earth? The resources required to terraform the moon would be so vast that only a truly global, unified effort could accomplish it. This might foster unprecedented international cooperation, or it could spark new rivalries for control over this most valuable of new worlds. The initial settlers might develop a strong sense of independence, perhaps even resenting Earth's continued influence. And what about Earth itself? Our night sky would be forever altered. Instead of a desolate rock, we would see a pale blue marble, sometimes with swirling white clouds, perhaps even the faint lights of cities on its surface. This transformed moon would be a constant reminder of humanity's incredible power, both to destroy and to create. It would serve as a poignant symbol of our reach and our ambition. The tides, which are subtly influenced by the moon's mass, wouldn't change dramatically with the addition of an atmosphere and water, but the sheer visual impact of a living moon would be breathtaking. It would fundamentally change our relationship with our nearest celestial neighbor, transforming it from an object of scientific curiosity and poetic wonder into a tangible extension of our living space. Ecologically, the creation of a new biosphere would be both a triumph and a massive responsibility. What kind of life would we introduce? Would we simply transplant Earth species? Or would we engineer entirely new forms optimized for the lunar environment? The potential for unforeseen ecological consequences, new lunar diseases, or unexpected evolutionary paths would be enormous. We would become planetary gardeners on the grandest scale imaginable, responsible for the health and vitality of an entire world. The ethical questions would be staggering. Do we have the right to impose Earth life on another body? What if we inadvertently destroy any unique, albeit microscopic, life that might already exist deep within the Moon? The very act of creation would be fraught with moral complexity. Ultimately, making the Moon habitable would be the ultimate testament to human ingenuity. It would be a project of such immense scale and duration that it would redefine humanity's place in the universe. We would transition from being mere inhabitants of one planet to true architects of worlds. The Moon, once a silent guardian, would become a thriving partner, a shining beacon of human ambition, reminding us that with enough will, enough science, and enough time, even the most barren of landscapes can be made to bloom. It would be a monumental step in securing humanity's long-term survival, expanding our civilization beyond a single planetary cradle, and writing a new chapter in the story of life itself. The question wouldn't just be if we could make the Moon habitable, but what kind of humanity would emerge from such a world-altering endeavor?